guys, and welcome to Lab 6. Today we're going to work with Hindered Settling or massic sedimentation in your blackboard. Why massic? Well, you're going to be working, you're going to observe as mass of sediments actually get, those particles get pushed together on the bottom of our sedimentation column. Last class we used the big column with 4 ports. It was flocculent sedimentation. Today we're going to use massic sedimentation, so we are going to use these cylinders. Okay, we're going to use these cylinders. We're going to fill them up with wastewater from tank 4. Okay, so remember this. You're going to gather up at least 10 liters of wastewater from tank 4, and then we're going to dilute our wastewater with distilled water. Okay, we're going to add a mixture of distilled water, so that will help us to those particles in suspension of intermediate concentration can actually will have force on it, so they will be pushed together at the bottom, so we could see the different zones in which these sediments will be settled. Okay. We can see here this emulates our 4 columns. Here this image, and we're going to measure time. So we're going to check how much time these particles actually take to settle as we add specific amounts, concentrations of distilled water. Okay. So in this case, we have our hindered zone. Hindered zone means this settling environment. Then as time increase, then we're going to have our transition settling, which is the sediments particles getting mixed and settled together, and compression setting. So when we have in the end this nice pack of sediments. Okay, procedure we're going to use for this. Why we do this? This procedure, this method, help us to calculate the area of a tank for sludge thickening, okay, which will be tank 4 here in our treatment plant, okay. So what happens, we're going to use area equals to our flow rate into a tank in liters times the time to reach the underflow concentration over our height interface. So you're going to measure the height of the columns. You're going to take times and the concentration. How do you think you're going to be doing it? How are you going to get that concentration? Anybody? You're going to work it with, as we usually do, okay? Concentration of solids over a particular volume of wastewater. Okay? So our first procedure is prepare our Gooch filters and our melting pots. Second, once you get 15 minutes in the oven, then 15 minutes on our desiccator, then you bring 10 liters of wastewater from tank number 4. Okay? You take the initial parameters, measure initial parameters, pH, turbidity, color, temperature, and what was it? ¿Alguien me dice? Somebody tell me en la práctica de hoy. It's color, turbidity, pH, and conductivity. Thank you very much. Once you get the initial parameters, you're going to then add step 4. You're going to add separate concentrations of the cylinders. 200, 800 milliliters of wastewater per 200 of distilled water. Then on the second one, the third one will be 600 milliliters of wastewater per 400 of distilled water. And the last one will be 200 of wastewater per 800 of distilled water, okay? So you're going to have those concentrations mixed in order to see the hindered settling over time, okay? Our first cylinder will be entirely with just the wastewater sample, so you can have it as you can observe how the particles actually settle, but since the concentration is greater, the settling will be lower, okay? So it's basically the opposite of our graph here, okay? Are we ready? Yes. All right, let's do this. Initial measurements, start with pH. We're going to use a pH meter, so you're going to hold it in until we get a steady measure. You wait more or less 30 seconds to a minute to obtain a steady measure of pH and also the temperature. Our sample from our tank 4 has a pH of 8.16, 17, and at a temperature of 23.7 degrees Celsius. We can also check our pH using our COD and multi-parameter photometer. Okay, we're gonna change it to pH. We're gonna calibrate it to 0, and then we're gonna compare our measurements from our handheld device and our photometer, multi-parameter photometer. And our photometer tells us it has a pH of 8.5. Although it's mentioning it's giving us a sign that it's out of scale, we can actually make it 0 again. However, our handheld device gives us a pH after a minute of 8.2 pH at 24 degree Celsius temperature. Again, 8.5. For color, we can use either our handheld color checker or we can use a multi-parameter photometer. Let's choose watercolor. Then let's calibrate it to 0. Once it's calibrated, then you just put your sample in and read. Give us 500 PCU units. As you can see, it's fairly dark, so that makes sense to have a really, really high number of PCU. So this time we're going to use these instruments for measuring turbidity and conductivity, okay? I put a 10 milliliter sample in this cuvette. So we're going to just put it in. It's the same principle of photometer, okay? It's going to use light to calculate. And it has an NTU of 670, okay? Turbidity, 670. And our conductivity so we have a conductivity of 1,562 microsiemens per second. Okay, that's what our equipment is actually measuring. A turbidity of 670 NTU and a conductivity of 1,561 microsiemens over centimeters. Steps for working our columns, settling columns. So in our first one, we're going to use 1 liter. We're going to pour directly 1 liter into our column. 1 liter of wastewater from our tank 4. It's important to mention that this wastewater, it's actually in the process of aeration. So all the particles are actually getting mixed. In our second column, we're going to add 800 milliliters of wastewater. And 200 milliliters of distilled water. On our third column, we're going to add 600 wastewater per 400 of distilled water. And our last one, 400 of wastewater for 600 of distilled water. You'll start notice that the concentration of our suspended solid concentration will be decreasing by adding our distilled water. This process is helpful in removing solids in our secondary treatment process. So once all of them are mixed, each column should be stirred on a 3-minute interval. All at once for demo processing, I'm just mixing it individually. Once all the columns are stirred and mixed, the running time for measuring the interval in which the settling will be occurring will be a top time of 30 minutes. So no more than 30 minutes. That's going to be our observation time. As you notice, once it stops, you'll notice that our last column with a greater amount of distilled water is going to start settling quicker than the other ones. You start noticing our first column that it has more concentration in compared to the others. So all the suspended sediments take more time to settle in the bottom. In our second column, you start seeing with the mixture that it creates a clarifying water on top. Then in our third one, it's a little bit quicker as it settles down. And in our last one, in just a matter of seconds, you can see that all the suspended solids are actually settling in the bottom.